Scientists have discovered that the average person takes 7 minutes to fall asleep, but those with anxiety or racing thoughts can take up to an hour. Tonight, we're changing that statistic for you with specially designed reality-bending experiments. Through the voices of characters you already know and trust, we'll guide you through visualization techniques that have been shown to reduce sleep onset by 15 minutes in clinical studies. This isn't just another sleep video. It's a journey through consciousness designed by animation lovers for animation lovers. The science-minded guide's reality perception experiments. Have you ever wondered if what you're seeing is actually real? Hey there, I'm Dr. Curiosity, and I've spent my entire career studying the fascinating boundaries between what we perceive and what's actually real. Adjusts glasses nervously. I've always been drawn to those weird little glitches in how our brains work. You know, those moments when what you think you're experiencing doesn't quite match up with reality. Our brains are constantly creating shortcuts and filling in gaps without us even realizing it. Take your visual blind spot, for instance. Right now, there's a part of your visual field that's completely blank, but your brain is filling it in so seamlessly that you never notice it. Pretty wild, right? It's like we're all walking around with these custom-made realities that our brains have constructed for us. The things we consider real are often just our brain's best guess at what's happening. Consider color perception. That vibrant red you see might look completely different to someone else. Or think about those optical illusions where two identical gray squares look different because of the surrounding context. Your brain isn't showing you the world as it is. It's showing you its interpretation. Let me walk you through a thought experiment called Mary's Room. Imagine a brilliant scientist named Mary who has spent her entire life in a black and white room. She knows everything there is to know about color, the wavelengths, how the brain processes them, everything. But she's never actually seen color. When Mary finally leaves her room and sees a red rose for the first time, she experiences something new. This raises a fascinating question. Is knowledge the same as experience? Can we truly understand something without experiencing it directly? Voice softening. Now let's consider another mind-bender called the Chinese room experiment. Imagine you're in a room receiving Chinese characters that you don't understand. You have a manual telling you exactly which characters to send back in response. To someone outside, it might seem like you understand Chinese, but you're just following instructions without comprehension. This makes us wonder, is processing information the same as understanding it? When we think we understand something, are we just running through sophisticated patterns? Speaking more slowly, some neuroscientists suggest that everything we experience might actually be a controlled hallucination. According to this view, your brain is constantly making predictions about reality, and what you perceive isn't the world itself, but your brain's best prediction of it. It's like we're all dreaming a very consistent dream while we're awake. Rhythm becoming more soothing. As technology advances, we're approaching what some futurists call the neural lace hypothesis, the idea that our perception might someday blend with technology, creating entirely new forms of reality. Imagine your consciousness expanded beyond your physical senses, merging with digital information streams. Voice getting gentler. You know this state you're in right now, as you're drifting towards sleep, it's actually a natural shift in perception. Your brain is already loosening its grip on constructing rigid reality. Those floating thoughts and strange images you notice aren't errors. They're glimpses of your mind releasing its need to organize everything into a coherent picture. By understanding these perception experiments, we can actually help our minds let go of those rigid reality constructs that keep us awake. Try visualizing your thoughts as leaves on a stream, watching them float away as your perception naturally shifts towards sleep. The Dreamy Guide's consciousness boundary explorations. As those reality constructs drift away, I'm Luna, your guide through the twilight of consciousness. Hi there, I've always existed somewhere between dreams and waking life. Have you ever noticed how thin the barrier actually is between different states of awareness? That's what fascinates me most about consciousness, those blurry boundaries where one experience bleeds into another. Let's explore something truly mind-bending. What if you aren't actually a single unified person at all? The split brain dilemma comes from an actual medical procedure called corpus callosotomy, where doctors cut the bundle of nerves connecting your brain's two hemispheres. After this procedure, something extraordinary happens. The brain literally functions as if it has two independent minds. The left side handles language and analytical thinking, while the right focuses on spatial awareness and creativity. Sometimes one hand might reach for an object, while the other pushes it away. It's like having two separate awareness systems sharing one skull, which really makes you question, who exactly is experiencing your life right now? Speaking of strange consciousness puzzles, imagine the entire universe expanding and contracting forever. Given infinite time, random fluctuations could potentially create a fully formed brain with false memories and sensations. This Boltzmann brain thought experiment suggests your consciousness might just be a random statistical blip that emerged with complete memories of a life you never actually lived. Your entire existence, childhood, relationships, this very moment, might be nothing more than false memories created by cosmic chance. My voice is getting softer now as we consider philosopher Robert Nozick's experience machine. Imagine a perfect simulation that could provide any experience you desire. Falling in love, climbing mountains, feeling completely fulfilled, all indistinguishable from reality. Would you choose to plug in? Many people hesitate, suggesting we value authentic experiences, even difficult ones, over simulated pleasure. There's something about knowing our experiences are real that matters deeply to us, even if that reality includes pain and struggle. As we drift closer to sleep, consider quantum immortality. This concept suggests consciousness might continue to exist only in branches of the multiverse where survival remains possible. In this view, you would only ever experience outcomes where you survive, creating a form of subjective immortality even as your physical body ages and faces mortality. Your awareness, simply alta, continues, flowing, always following the path where it still exists. Everything we're discussing now, these thoughts, these words, this moment of near sleep, might have happened countless times before and will happen again. The philosophical concept of eternal return suggests each moment in your life repeats infinitely. Every choice, every breath, every dream cycling through eternity. Rather than causing despair, there's something soothing about this endless rhythm. As we approach that magical boundary between wakefulness and sleep, the hypnagogic state, your consciousness naturally begins to transform. This transitional phase brings vivid imagery, gentle auditory hallucinations, and a pleasant detachment from reality. By exploring these consciousness boundaries, we allow our minds to surrender to sleep more easily. The comforting guide's final journey into dreams. That pleasant detachment from reality is exactly where our final journey begins. I'm Ember, your guide for these last steps into dreams. Wrapped in my favorite blanket with heavy eyelids, I specialize in that final gentle transition where thinking transforms into dreaming. While my colleagues have shown you fascinating experiments about perception and consciousness, I'm here to help you let go of all those intriguing questions. Sometimes the path to true rest requires releasing our need to understand everything. Have you ever considered that everything you think you know might have been created just moments ago? Last Thursdayism suggests the entire universe, including all your memories and evidence of the past, could have been fabricated complete with every detail intact. But rather than finding this disturbing, there's something strangely comforting about it. If the past itself might be an illusion, then perhaps today's worries and yesterday's regrets can be set aside just as easily as we set aside dream fragments upon waking. Let your mind drift now, like wandering through an infinite library containing every possible book that could ever exist. Somewhere on these endless shelves are volumes detailing your perfect tomorrow, stories of your greatest accomplishments, even this very moment described in infinite variation. As you browse these imaginary shelves, notice how your thoughts become less focused, more dreamlike, drifting between the spaces of these cosmic books. In this vast universe, perhaps there are infinite versions of you, right at this moment, each one experiencing their own journey towards sleep. Some doppelgangers might be just beginning this recording, while others are already deep in dreams. You're connected to all of them, existing simultaneously across countless realities, each one valid, each one real in its own way, each one gradually surrendering to sleep. Imagine now, time flowing backward, like waves receding from shore, each moment undoing the one before it, the tensions of your day lifting away, muscles releasing their hold, thoughts becoming lighter, floating upward, each breath taking you further from wakefulness, reversing the day's accumulated stress. You can rest assured knowing that you exist in a reality where you continue to exist. The anthropic shadow reminds us that we can only observe a universe where humanity has survived. This perspective brings a deep sense of safety, knowing that in this timeline, in this universe, you are here, protected, drifting toward dreams that await you. All these reality-bending concepts weave together into a gentle tapestry of comfort. The unfalsifiable past, the infinite possibilities, your many selves across realities, the reversibility of time, your place in a universe that allows your existence. All these ideas invite you to surrender your conscious mind's grip on wakefulness. The reality construction machine. How your brain creates what you see. What if I told you that right now, your brain is actively building the reality you think you're just observing? The world you see isn't actually what's out there. It's a construction project happening inside your head. We tend to think our eyes work like cameras, just passively recording whatever's in front of us, but that's not even close to how vision actually works. Your brain is constantly making educated guesses about what should be in your environment based on tiny snippets of sensory information, and then it builds an entire reality for you to experience. Think about this. Your eyes actually have natural blind spots where your optic nerve connects to your retina. There's a spot in your visual field where you literally cannot see anything. But you never notice this massive hole in your vision because your brain automatically fills it in with what it thinks should be there. It's creating parts of your reality that don't exist in your actual sensory input. Your brain isn't showing you what's there. It's showing you what it thinks is probably there. Scientists like neuroscientist Anil Seth have started referring to perception as a form of controlled hallucination. This might sound extreme, but it's actually a perfect description of what's happening. Your brain is essentially hallucinating your reality, but it's keeping these hallucinations in check by constantly comparing them against sensory input. When you're dreaming, these hallucinations continue, but without the sensory checks and balances, which is why dreams can get so bizarre and untethered from physical laws. You can actually experience this reality construction process with a simple experiment. Focus straight ahead while holding your thumb out to the side in your peripheral vision. You might think you can see your thumb clearly, including its color, but you actually can't. Your peripheral vision has very few color-detecting cells. What's happening is your brain is filling in what it expects to see. It's not showing you reality, it's showing you a prediction of reality. Another fascinating example involves motion. When something moves quickly across your vision, your brain doesn't actually see the movement continuously. Instead, it receives a series of snapshots and then actively creates the perception of smooth motion between them. This is similar to how animation works, with individual frames blending into continuous movement. Your perception of smooth reality is being constructed from discontinuous information. This reality construction process happens through predictive processing. Your brain uses your past experiences to predict what you'll see, hear, and feel before you actually experience it. These predictions travel from higher brain regions down to your sensory cortices, essentially telling them what to expect. When sensory information matches these predictions, you perceive reality smoothly. When there's a mismatch, your attention gets directed to resolve the error. What's truly fascinating is that functional MRI studies have shown the same brain regions active during waking perception, particularly your visual cortex and thalamus, remain active during dream construction. During dreaming, your thalamus, which normally relays sensory information to your cortex, continues sending signals, but these signals are generated internally rather than coming from your eyes. Your visual cortex processes these internal signals just as it would process external information, creating vivid visual experiences despite your eyes being closed. This whole reality construction system actually begins to shift as you get tired. As fatigue sets in, the careful balance between prediction and sensory input starts to tilt. Your brain gradually reduces its emphasis on incoming sensory data and relies more heavily on its internal predictions. This is why tired people are more prone to misperceptions and why objects might seem to briefly transform or change when you're exhausted. The constraints on your brain's hallucination machine are loosening. One particularly interesting study used binocular rivalry tests where different images are shown to each eye to demonstrate how perception becomes more unstable when we're tired. Normally, your brain switches between seeing one image or the other, but with fatigue, these perceptions become more mixed and ambiguous. Your brain's ability to construct a coherent, stable reality literally diminishes as sleep pressure builds. This brings us to how reality-bending experiments can actually help you fall asleep. When you engage with perceptual illusions or attention exercises that challenge your brain's reality construction process, you're essentially helping it transition from one mode to another. These experiments gradually shift your brain from its daytime reality construction mode to its nighttime dream construction mode. They act as a kind of cognitive bridge, helping your brain release its grip on constructing a consistent external reality and embrace the internal reality building of dreams. The hypnagogic gateway, your brain's transition from wakefulness to sleep. The shift from wakefulness to sleep isn't the simple on-off switch most people imagine. It's more like crossing through a strange neurological borderland where your brain waves physically transform from one pattern to another. During these precious few minutes of transition, your mind generates experiences so unusual that many ancient cultures believed they represented messages from another realm entirely. This mysterious transitional period has a name, hypnagogia, and it's a measurable brain state that most of us experience regularly without recognizing its significance. Those geometric shapes and half-formed images that dance behind your closed eyelids aren't random noise. They're actually visual evidence of your brain's remarkable transition process. When neuroscientists track what happens during this transition, they observe a fascinating cascade of changes in your brain's electrical activity. Initially, your alert mind generates beta waves, the rapid oscillations associated with focused attention and logical thinking. As you begin to relax, these shift to alpha waves, which indicate a more relaxed but still conscious state. The real magic happens when your brain starts producing theta waves, the slower rhythm that signals you're entering the drowsy pre-sleep zone where hypnagogic experiences occur. These brainwave shifts don't happen uniformly across your entire brain, which explains the unusual perceptual experiences that characterize hypnagogia. Parts of your visual cortex might be in theta, while your auditory processing remains in alpha, creating a fragmented experience where perception works differently than during full wakefulness or complete sleep. Most people experience common types of hypnagogic hallucinations as they drift towards sleep. You might see geometric patterns forming and dissolving, faces morphing into one another, or landscapes that appear with startling clarity despite your closed eyes. These aren't signs of mental disturbance. They're completely normal manifestations of your brain's changing processing mode. As your sensory systems begin disconnecting from external stimuli, your brain turns inward, generating its own visual and sensory content without the constraints of matching external reality. What makes this transition especially fascinating is how it reveals the shifting balance between different neural networks in your brain. Throughout your day, your task-positive network dominates your experience. This is the system that helps you focus on specific tasks and interact with the external world. But as sleep approaches, this network's activity gradually diminishes. Simultaneously, your default mode network, associated with imagination, self-referential thought, and internal narratives, becomes increasingly active. This neural handoff explains why your thoughts become more dreamlike and associative during hypnagogia. The logical connections that structure your waking thoughts become looser, allowing your mind to wander across memories and scenarios that might seem unrelated during full wakefulness. Scientists studying this transition using functional MRI can actually observe these network activity shifts in real time, watching as your brain pivots from external to internal processing. The experience of hypnagogia varies dramatically between individuals. Some people report extraordinarily vivid imagery that feels almost like watching a movie behind closed eyes. Others might experience primarily auditory hallucinations, snippets of conversations, music, or their name being called. For some, the dominant sensation is physical, feeling like they're floating, spinning, or suddenly jerking as muscle tone begins to decrease. What's particularly interesting is that this transitional state isn't just something that happens to you. It's something you can learn to recognize and even influence. By becoming aware of the subtle signs that you're entering hypnagogia, you can develop what sleep researchers call sleep onset awareness, the ability to remain consciously aware as you transition into sleep. This awareness doesn't prevent sleep. Instead, it allows you to experience the fascinating borderland between wakefulness and dreams with greater clarity. By paying attention to how your thoughts naturally change as you approach sleep, you can actually facilitate the transition. When you notice your thinking becoming more associative and dreamlike, you can work with that tendency rather than fighting it. Instead of jerking yourself back to logical thinking when your mind wanders, you can allow those wandering thoughts to carry you deeper into the hypnagogic state. The practical implications of understanding hypnagogia extend beyond mere curiosity. For people who struggle with insomnia, learning to recognize and work with this natural transition rather than resisting it can transform their relationship with sleep. Instead of becoming frustrated by the unusual sensations and thoughts that arise during sleep onset, they can recognize these experiences as normal signposts along the path to sleep. The dreamlike nature of optical illusions. When waking perception fails. While hypnagogia reveals how our perception naturally distorts as we drift towards sleep, there's something equally fascinating happening even when we're wide awake. Have you ever stared at the famous duck-rabbit drawing and watched as your perception suddenly flips between seeing a duck and seeing a rabbit? That moment of perceptual switching isn't just a curious visual trick. It's actually a window into the same reality-bending mechanisms that construct your dreams each night. These bistable perception illusions, where your mind toggles between two equally valid interpretations of the same unchanging image, demonstrate something profound about how your brain works. When you look at a Necker cube, that simple line drawing of a cube that seems to flip its orientation despite never changing on the page, you're witnessing your perception break free from the constraints of fixed reality. This mirrors what happens in dreams, where a person can transform into another, or an object can simultaneously be two different things without any contradiction. What's particularly striking about these illusions is that they're not just conceptually similar to dream experiences. They're neurologically related too. Research has revealed that certain optical illusions actually trigger the same brain regions that become active during early dream states. When your perception shifts while viewing these ambiguous images, your brain engages in similar interpretive gymnastics as it does when constructing dream scenarios. Think about motion illusions for a moment. When you stare at a spiral pattern and then look away, the world appears to expand or contract even though nothing is actually moving. This phantom motion sensation shares remarkable similarities with how dreams create the experience of movement. In your dreams, you might feel like you're running, flying, or falling, despite your body being completely still in bed. Both experiences, the illusory motion and the dreamed movement, stem from your brain's ability to construct convincing sensations of movement without any corresponding physical input. Color and brightness illusions reveal another fascinating parallel. The checker shadow illusion, where two squares that appear to be different shades actually have identical brightness values, demonstrates that our perception of light and color is entirely relative rather than absolute. Your brain judges brightness based on context, not on objective measurement. Dreams operate under this same principle of relative perception. Colors can shift dramatically based on the internal logic of the dream environment rather than following real-world physics. These perception quirks aren't just interesting coincidences. They reflect fundamental principles about how consciousness works. Your waking perception and your dreaming mind aren't separate systems, but variations of the same underlying neural architecture. The difference lies mainly in the presence or absence of sensory input from the outside world. When you experience an optical illusion, you're essentially catching your brain in the act of constructing reality, rather than simply recording it. The mistakes your brain makes during these moments reveal its operating principles, the same principles that allow it to generate entire dreamscapes while you sleep. Consider what happens when you look at the famous Kaneza triangle, where your brain perceives a white triangle that isn't actually there, defined only by the arrangement of Pac-Man-like shapes. This illusory contour demonstrates your brain's powerful tendency to complete patterns and create coherent structures, even when the sensory information is incomplete or ambiguous. This same completion mechanism allows your dreaming brain to construct elaborate scenarios from fragments of memories and emotions. What's particularly remarkable is how these illusions don't just affect visual processing, but can influence your entire perceptual framework. Just as dream logic can seamlessly blend contradictory elements without triggering your rational mind to object, certain optical illusions can temporarily override your rational understanding of physical reality. You might know intellectually that the lines in the Mueller-Lyer illusion are the same length, but your perception insists otherwise. Not all illusions affect us equally, though. Some seem to have a particularly powerful effect on our state of consciousness. Those illusions that demonstrate bistable perception, where reality seems to flip between equally valid interpretations, appear to be especially effective at shifting our brains toward more dreamlike processing. The ambiguity they present forces our perceptual systems to work harder, sometimes inducing a slight detachment from our usual rigid interpretations of sensory input. This connection between optical illusions and dream states isn't just academically interesting. It has practical implications for understanding how we might transition more effectively between wakefulness and sleep. The illusions that most closely mirror dream phenomena, those dealing with bistable perception, relative awareness, and constructed motion, provide the most insight into how our conscious and unconscious minds process reality. When you engage with these specific types of illusions, you're essentially giving your brain a workout in the same neural pathways that will later construct your dreams. It's almost like a warm-up exercise for the dream generation mechanisms that will take center stage once you fall asleep. Perceptual shifts in the tired brain. When reality starts to dream, those dream generation mechanisms aren't just dormant until you're fully asleep. They're actually warming up right now as you listen, gradually shifting into gear as your tiredness increases. Ever notice how your thoughts become stranger and less logical the more exhausted you get? This isn't just your imagination playing tricks on you. It's your brain literally processing reality differently. When we think about the transition between being awake and falling asleep, we typically imagine it as flipping a switch. You're either awake or you're not. But the truth is far more fascinating. Your brain doesn't simply shut down all at once. Instead, it undergoes a gradual transformation, with different processing systems switching modes at different rates. This creates a spectrum of consciousness states where the line between waking perception and dreaming becomes increasingly blurred. As tiredness sets in, one of the first things to change is your attention. That laser-focused concentration you might have had at the beginning of this video has likely softened. Your peripheral awareness probably isn't as sharp as it was before. This narrowing of attention is your brain's way of conserving energy, directing its limited resources to what it deems most important as fatigue increases. But perhaps the most intriguing shift happens in how your tired brain connects ideas and recognizes patterns. Research indicates that as fatigue sets in, your pattern recognition becomes more abstract and associative. Rather than making strictly logical connections between concepts, your tired brain begins drawing more creative, unexpected links. This is why some of your best creative insights might come when you're exhausted. Your brain has literally shifted into a mode where it prioritizes associative thinking over rigid analytical reasoning. This change doesn't just affect how you think, it transforms what you remember and how susceptible you are to suggestion. Studies show that tired brains exhibit increased vulnerability to false memories and misleading information. This mirrors what happens during dream states, where your mind readily accepts bizarre scenarios without question. As you grow more tired watching this, your critical faculties gradually power down, making you more receptive to information without subjecting it to your usual rigorous analysis. time perception undergoes fascinating distortions. As well, have you ever been extremely tired and felt like minutes were dragging into hours? Or perhaps experienced the opposite, suddenly realizing a significant amount of time has passed in what felt like mere moments? These temporal distortions occur because the neural mechanisms that track time become less precise as fatigue increases. Your internal clock literally runs differently when you're tired. Your sensory thresholds undergo curious shifts too. While some sensory inputs become dulled, maybe you're not noticing background noises as much now, others might become temporarily heightened. This uneven adjustment creates a perceptual landscape that increasingly resembles dreams, where certain details stand out with extraordinary vividness, while others fade completely from awareness. These perceptual shifts don't happen uniformly across your brain. Some regions maintain their waking processing modes, while others have already begun transitioning towards sleep-associated patterns. This creates a hybrid state of consciousness where parts of your brain are essentially dreaming, while others remain functionally awake. The fascinating thing about understanding these changes is that we can actually use them to our advantage. Rather than fighting against the tide of drowsiness, we can intentionally lean into these perceptual shifts when we want to fall asleep. By recognizing the signs that our brain is naturally transitioning, like increased associative thinking or narrowed attention, we can actively facilitate the process instead of resisting it. Think about it this way. Your perception right now exists somewhere on a spectrum. At one end is the hyper-alert, analytically dominant processing of a fully refreshed mind. At the other end is the immersive, internally generated experience of dreaming. The more tired you become, the further you move along this spectrum. Your reality isn't being constructed with the same tools it was an hour ago. What's happening in your mind as you watch this is a gradual shift from externally focused, logical processing toward an increasingly associative, internally generated experience. The tired brain begins to loosen its grip on sensory data, placing more emphasis on internal models and associative networks. This doesn't mean your perception becomes less real, just that it's constructed differently, prioritizing different aspects of experience. The shared architecture, scientific bridges between dreams and perception. The line between your dreams and your waking reality isn't nearly as defined as most of us assume. Recent neuroscience has revealed something truly fascinating. Your brain doesn't actually have separate systems for processing dreams versus processing what you're seeing right now. This shared neural architecture explains why reality can sometimes feel dreamlike and why dreams can feel surprisingly real. When neuroscientists started mapping brain activity during both waking perception and dreaming, they expected to find distinct networks. Instead, they discovered the same core systems operating in both states. Your brain essentially uses the same tools, but in different configurations, like a versatile instrument that can play both classical and jazz depending on the settings. This overlap begins with your brain's predictive coding system. Right now, as you're watching this video, your brain isn't passively recording information like a camera. It's actively constructing what you're experiencing based on incomplete sensory input, creating predictions based on past experiences and expectations. When something unexpected happens, your brain updates its model. During dreams, this exact same predictive system remains active, but without the checks and balances of incoming sensory data. Your brain is still making predictions, but they're based entirely on internal models rather than external reality. Even more interesting is how the default mode network, often called your brain's imagination center, bridges these two states of consciousness. This network is active right now if your mind occasionally wanders from the content of this video. It's the system that allows you to daydream about tomorrow's plans or replay memories from your past. Neuroscience research shows this same network lights up intensely during REM sleep, creating the vivid mental imagery and narrative structure of your dreams. The striking similarity suggests that dreaming might actually be an intensified form of the mind-wandering you experience throughout your day. The emotional dimension of this shared architecture is particularly revealing. Your emotional processing centers don't shut down when you sleep. They actually become more active during certain dream stages. The amygdala and other limbic structures color your dream experiences with emotional significance, just as they influence your waking perceptions. This explains why emotional events from your day often reappear in your dreams, sometimes in symbolic or exaggerated forms. Your brain processes emotional experiences through similar mechanisms, whether you're awake or asleep. The way you experience yourself as present in both dreams and reality also shares remarkable similarities. The neural mechanisms that create your sense of embodiment, of physically existing in space, remain active during dreaming. This explains why you typically still experience a first-person perspective in your dreams, even when your dream body might do impossible things like flying. The same brain regions that track your position in physical space during wakefulness continue creating this sense of presence during dreams. Memory processing represents another fascinating bridge between these states. Your brain doesn't just store memories like files in a cabinet, it actively reconstructs them each time you remember something. This reconstruction process happens in remarkably similar ways during both wakefulness and sleep. Memory consolidation, the process of transferring experiences from short-term to long-term memory, occurs during specific sleep stages. But similar processes happen during quiet wakefulness when your mind isn't actively engaged with new information. These connections have profound implications for understanding consciousness itself. If your brain uses the same fundamental architecture to construct both your dreams and your perception of this video right now, it suggests that consciousness isn't a fixed state, but exists along a continuum. The differences between dreaming and waking awareness might be more about degree than kind, varying levels of the same underlying processes rather than completely different mental states. This shared architecture also explains why certain experiences can feel strangely dreamlike even when you're fully awake. Those déjà vu moments, the strange familiarity of new places, or times when reality briefly takes on a surreal quality. These aren't glitches in your perception. They're moments when your brain's reality construction system temporarily shifts toward patterns more common during dreaming. Consider how this knowledge might transform your understanding of both sleep and wakefulness. By recognizing the continuous nature of consciousness across these states, you gain insight into how your mind works in all conditions. This awareness offers new approaches for addressing both sleep disorders and perceptual difficulties. For instance, certain meditation practices that focus on recognizing the constructed nature of perception can help ease the transition between wakefulness and sleep by making you more familiar with how your mind creates both experiences. The boundaries between dreaming and waking aren't walls, but permeable membranes, with information and processes flowing continuously between them. Your dreams influence your waking reality through emotional processing and memory consolidation, while your daily experiences provide the raw material that your dreams reshape and reprocess each night. Visual patterns that induce drowsiness, the science of sleep-inducing imagery. Nature didn't just evolve our brains to process reality and dreams with the same machinery. It also embedded a fascinating vulnerability into our visual system. The same patterns found in gently moving leaves, flowing water, and drifting clouds contain a mathematical secret that can literally switch your brain from alertness to drowsiness without you even realizing it's happening. This isn't some kind of psychological trick, it's hardwired biology. Specific visual patterns can directly influence your brain's electrical activity, triggering state changes that promote the transition to sleep. It's like a secret backdoor into your consciousness, bypassing your logical mind entirely. This has profound implications for how we design our bedtime environments. What you choose to look at in the hour before bed could be either helping or hindering your ability to fall asleep, regardless of how tired you actually feel. Let's examine what's happening in your visual cortex when you gaze at certain patterns. Fractal patterns, those self-similar shapes that repeat at different scales, are particularly powerful sleep inducers. These patterns aren't random. They have a specific mathematical complexity that your visual processing system responds to in a unique way. When you stare at patterns with the right fractal dimension, like those found in nature, your visual cortex enters a more relaxed processing state. It's as if these patterns were specifically designed to soothe the visual system. The effect goes beyond simple relaxation. Visual rhythms at specific frequencies can actually entrain your brain waves, gradually shifting them towards sleep-associated patterns. This is part of why watching gentle ocean waves or a campfire can make you feel drowsy. The rhythm of the visual movement actually synchronizes with your brain's natural electrical patterns, pulling them toward the frequencies associated with early sleep stages. It's like your brain is being gently tuned to a different channel. The contrast and edge characteristics of what you're viewing also play a crucial role. Research shows that soft edge, low-contrast imagery reduces cortical activation compared to high-contrast, sharp-edged imagery. This explains why harsh, bright screens with sharp graphics can keep you alert, while softer, more diffuse visuals promote relaxation. High-contrast imagery forces your visual system to work harder, maintaining higher levels of alertness and processing energy. The softer imagery, by contrast, allows your visual system to gradually power down. There's also an important concept called visual comfort that helps explain this phenomenon. Certain color combinations and movement patterns require less neural processing energy than others. Your brain is constantly trying to be efficient with its resources, and processing visually complex or high-contrast scenes requires significant energy expenditure. The more processing power required, the more alertness is maintained. Conversely, visuals that require less processing energy allow the brain to conserve resources and shift towards sleep-ready states. We can actually observe how these visual patterns affect us by tracking gaze behavior. As drowsiness increases, your eye movements physically change. You transition from focused, foveal attention, looking directly at specific details, to more diffuse peripheral awareness. This shift in gaze behavior isn't just a response to getting tired. It can be influenced and accelerated by the type of visual stimuli you're observing. Certain patterns naturally promote this transition from focused to peripheral awareness, essentially preparing your visual system for sleep. This documentary's visuals aren't chosen randomly. They're deliberately designed based on these scientific principles. The flowing, natural patterns you're seeing right now, the gentle color transitions, and the specific rhythm of visual changes are all calibrated to gradually guide your visual system toward a sleep-ready state. We're not just telling you about these effects, you're experiencing them as you watch. What makes this even more fascinating is that different visual patterns work better for different people. Some individuals respond more strongly to flowing water patterns, while others find fractal plant-like imagery more effective at inducing drowsiness. Some people even find that certain geometric patterns with specific mathematical properties are particularly powerful sleep inducers. It's like each person has a unique visual sleep key that unlocks their transition to drowsiness. The timing of exposure to these patterns matters too. Your brain's susceptibility to visual entrainment changes throughout the day, with the hours before your natural sleep time being when these patterns have their strongest effect. This is why flipping through visually stimulating content right before bed can be so disruptive. You're essentially sending the wrong signals to your brain precisely when it's most receptive to visual cues about sleep readiness. Sensory manipulation experiments mirroring the sleep onset process. While visual patterns can guide your brain towards sleep, there's a whole other dimension to sleep induction that goes beyond what you see. Scientists have discovered that we can manipulate every sensory channel in ways that mimic what happens naturally during sleep onset. This boundary between being awake and drifting off isn't nearly as solid as most people think. It's more like a permeable membrane that can be crossed gradually through carefully designed sensory experiences. One of the most fascinating demonstrations of this principle is the Ganzfeld experiment. Researchers place half ping-pong balls over participants' eyes and shine a uniform red light at them while playing white noise through headphones. This creates a completely uniform sensory field, and something remarkable happens. Within minutes, many participants begin experiencing vivid hallucinations similar to those that occur during hypnagogia. Without distinct sensory input to process, the brain begins creating its own internal imagery, effectively simulating the early stages of dreaming while the person remains technically awake. This sensory manipulation extends beyond just what we see. Our ears undergo significant processing changes as we transition to sleep, and researchers have found ways to artificially induce these shifts. Specific low-frequency sounds have proven particularly effective at promoting the relaxation and drowsiness that characterize sleep onset. These frequencies essentially trick the auditory processing centers of the brain into adopting the same patterns they would naturally display when you're drifting off. It's almost like giving your brain a template to follow. Here's how your auditory system should be functioning right now. What's happening with your sense of touch is equally fascinating. As you transition towards sleep, your brain's processing of tactile information naturally diminishes. Your awareness of your body begins to fade, starting with the extremities and gradually moving inward. Scientists have found ways to artificially induce this same pattern in fully awake subjects through specific forms of sensory manipulation. By systematically reducing certain types of tactile input while enhancing others, they can recreate the characteristic body awareness shifts that signal to your brain that sleep is approaching. Temperature manipulation offers another powerful avenue for sleep induction. Our bodies undergo specific temperature changes as we prepare for sleep. Most notably, our core temperature drops slightly while blood flow increases to our extremities, helping to dissipate heat. Experiments have shown that artificially cooling the extremities in specific patterns can effectively mimic this natural process, promoting drowsiness by convincing the body that sleep onset is already underway. This temperature manipulation works because it aligns with what your body expects to happen as you approach sleep. Perhaps the most intriguing aspect of sleep transition is how our senses become less bound together. In normal waking consciousness, we experience highly integrated multisensory perception. What we see, hear, and feel are tightly synchronized. During sleep onset, this integration loosens, creating those strange dreamlike disconnections where sensory experiences don't quite match up. Researchers have developed techniques to deliberately induce this loosening of sensory binding in awake subjects, effectively recreating the dreamlike quality of perception that characterizes early sleep stages. Throughout this documentary, we've been carefully applying these principles. The visuals you're seeing have been designed with specific patterns and timings to guide your visual system towards sleep-appropriate processing. The audio you're hearing contains subtle frequency components that encourage your auditory system to shift towards sleep-like patterns. Even the pacing of information has been calibrated to gradually reduce your cognitive load, mimicking the natural decrease in analytical thinking that occurs as sleep approaches. These aren't just theoretical concepts. They're practical techniques based on our understanding of how sensory processing reorganizes during sleep onset. When you experience difficulty falling asleep, what's often happening is that your sensory systems are stuck in their waking configurations. By understanding how these systems naturally transition and learning to facilitate those transitions, you can significantly improve your ability to cross the threshold into sleep. The beauty of these sensory manipulation experiments is that they reveal something profound about consciousness itself. Sleep isn't a binary state that you either are or aren't in. It's a complex reconfiguration of multiple sensory and cognitive systems, each transitioning at its own pace. By recreating aspects of this transition in controlled settings, scientists have shown that the boundary between wakefulness and sleep is far more permeable than we once thought. Your senses don't simply switch off when you fall asleep. They undergo a sophisticated transformation that scientists can now partially recreate in fully conscious subjects.